Hello and welcome to my channel. In this video we will solve problem 1 and 2 of miscellaneous exercise on chapter 14 in 11th class math. So the first problem is a box contains 10 red marbles, 20 blue marbles and 30 green marbles. 5 marbles are drawn from the box. What is the probability that first all will be blue, second at least one will be green? Okay. So what we are given is a box which contains 10 red marbles, 20 blue marbles, 30 green marbles, right? Then 5 marbles are drawn from the box, and then we are asked what is the probability that first all will be blue, second at least one will be green. Okay, so let us start and solve this problem here. Now what we have to do first is we have to find the number of ways in which we can select the 5 marbles from the total marbles from the box. Okay, so we have to use the concept of permutation and combination. So here we have to use combinations because the order is not important. Okay, so now let us see what is the number of ways of drawing 5 marbles from the total marbles. Okay, so the number of ways of drawing 5 marbles from the total. So how many marbles are there? If we take the sum 10 plus 20 plus 30, that will give us 60. So drawing 5 marbles from the total 60 marbles is what? So by the combination concept we get the total 60. C means combination 5. Okay, because we are selecting 5 marbles from 60. So this is the number of ways of drawing 5 marbles from the total 60 marbles. Now what we will do is we will take the event of selecting 5 marbles from the box. So let E be the event of selecting 5 marbles from the box. Okay, so therefore what we will get is the number of elements in this set will be what? The number of elements in this set will be equal to the number of ways of drawing 5 marbles, right? So because you will have different ways of drawing the 5 marbles from the 60, so this number of elements in the set E will be nothing but 60 C5. Okay, right. Now let us go to the first sub problem. So in the first sub problem, what is given? All will be blue. So all will be blue. Okay, now for this we have to take we have to find the number of ways of selecting all blue marbles, right? So let us write the number of ways of drawing 5 blue marbles from the, how many total blue marbles are there? 20, right? From the 20 blue marbles is 20 C5. Okay, 20 C5. So now let us consider the event of selecting the 5 blue marbles from the 20 blue marbles. So see, this is nothing but the event of selecting all 5 blue marbles. Okay, So you know the formula for finding the probability of selecting all blue marbles, right? So it is nothing but number of elements in the set F. Okay, first of all, what is the number of elements in set F? It is 20C5, right? Because the number of ways of selecting all 5 blue marbles from all 20 blue marbles is 20C5. So number of elements in this set F is 20C5, and now we can go to the probability. So now probability of selecting all blue marbles is nothing but number of elements in set F divided by number of elements in the set E. Okay, so this is equal to number of elements in F is what, 20C5, and number of elements in set E is 60C5. Okay, so this is the answer. Now let us go to the second sub problem. So in the second sub problem, we have to find the probability that at least one will be green, right? At least one will be green. At least one will be green. Okay, so for this what we have to do is we have to find the number of let us see. Okay, so this is a little different type of problem, second sub problem. So what we have to find is nothing but probability that at least one will be green. So this probability is equal to 1 minus probability that none of the 5 marbles are green. Okay, none of the 5 marbles are green, right? So now what we have to find is the number of ways of selecting the 5 marbles in such a way that none of them are green. So the number of ways of selecting 5 marbles out of which none of them are green. So in how many ways you can select that? So we now have to only look at the red marbles and the blue marbles. So we have to select the 5 marbles from the total 30 marbles, right? So that is 10 plus 20, 30 marbles. So is what, 30. From 30 we have to select the 5 because none of them should be green. Okay, so we are deleting the, or we are not taking the 30 green marbles. So this is the number of ways of selecting 5 marbles out of which none of them are green. Now let us take event here. So let G be the event event of selecting the 5 marbles out of which none of them are green. Okay, so what we have to now find is this. So we will get this probability that at least one marble is green is equal to 1 minus the probability not probability, yeah, probability is there, we can write none of the 5 marbles are green, none of the 5 marbles are green. So this is already written, right, in the previous page. So we will get 1 minus number of elements in G divided by number of elements in E. So this is the probability of selecting 5 marbles as none of them are green. So 1 minus, what is the number of elements in G? So number of elements in G is nothing but this 30C5, right? So what we will get is 1 minus 30C5 divided by 60C5. Okay, so this is the answer. So that's it, we have solved the first problem. Now let us go to the second one. So 4 cards are drawn from a well shuffled deck of 52 cards. What is the probability of obtaining 3 diamonds and 1 spade? Okay, so what is given is 4 cards are drawn from 52 cards. What is the probability? We have to find the probability of obtaining 3 diamonds and 1 spade. So what we will write is first the number of ways of drawing 4 cards from the 52 cards. This problem is similar to the previous one. Okay, so the number of ways of drawing 4 cards from the 52 well shuffled cards is what? So it is 52C4, right? We are selecting 4 cards from the total 52. So number of ways of drawing 4 cards from the 52 cards is 52C4. Now what we will do is we will take the event of drawing 4 cards from the 52 well shuffled cards. Let E be the event of drawing 4 cards from the 52 well shuffled cards. Okay, so therefore what is the number of elements in this set? It is 52C4. Okay, now let us look at the second part of the problem. So what is the probability of obtaining 3 diamonds and 1 spade? So let us see the number of ways of drawing 3 diamonds and 1 spade from the 52 cards. So the number of ways of drawing 3 diamonds and 1 spade so is equal to what? So you know that there are 13 diamond cards, right? 13 diamond cards are there. So total 13 diamond cards. From that we have to select 3. So the number of ways of selecting 3 diamonds from the 13 diamonds is 13C3. And okay, and means into, right? You can write also multiplication like this. So now and 1 spade. So there are how many spades in the shuffled, well shuffled or 52 cards? There are 13 spades. So 13C1. Okay, now let us take the event. Let F be the event of drawing 3 diamonds and 1 spade. Okay, so therefore number of elements in set F is equal to this 13C3 into 13C1. Okay, now we can find the probability. So therefore the probability, or we can write it in terms of notation. Okay, therefore probability of drawing 3 diamonds and 1 spade is equal to this n f, number of elements in set F, divided by number of elements in set E. So that is nothing but 13C3 into 13C1 divided by number of elements in E is what? 52C4. 52C4. Okay, so this is the solution. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.